Okay, so today I'm going to ask you a variety of questions on the topic of heat. Although I want you to answer the questions to the best of your knowledge, this exercise isn't about me testing you on how well you know the subject. It's more about me to see if I can ask you the right questions to gain as much insight as I can about what you know about the subject. That's all good? I might even trick you sometimes, so...
Yeah.
Okay, so we're going to talk about heat. You covered this. You should have covered this last year and like 3 years ago. So don't stress if you don't know anything, because I don't expect you to know everything that I ask you. All right?
Yeah.
Feeling okay?
Yeah.
All good. Okay. So are you right for me to start?
Yeah.
Okay. So we'll start off easy. Can you tell me any sources of heat that you or any person might encounter on a day-to-day basis?
Like things that like a heat, like hot.
Yeah. So things that like create heat.
Oh, the sun.
Yeah, perfect.
A fire.
Yes, good one.
A bonfire, like
Yes, a bonfire. Yeah.
outside fire.
Yeah.
A heater. Oh,
Yeah.
a heater.
Yes, good one.
Insulation, like
Insulation.
insulation. Yeah.
Mm-hmm. Yeah,
And
that's heat.
that's it.
That's so good. Good job. Great start. Now, if I was to give you a nice big blanket, would we say that that's a source of heat?
No,
Why not?
because that's not the thing keeping you warm. It is, but I mean, it's also your body that's helping, like, keep yourself warm.
Right. Cool. Good job.
Because the blanket's not hot just by itself. It has to be like used.
Okay.
Yeah.
Great. So I'm not sure about you, but I'm feeling pretty cold. So can I get you to rub your hands together? Do you feel the temperature change?
Yeah.
Yeah. Can you explain to me in as little or as many words as you like what is actually happening?
Friction.
Friction.
Yeah.
Can you tell me any more?
Well, from rubbing your hands together, it's creating heat because you're going really fast. Say if you were to rub two sticks together, it would create fire because, well, if you rub them together really fast, it could create a source of heat or fire.
Wow, good job. That's so good. Now, if I was to give you a block of ice, it's too cold for me to actually give it to you, but if I was to give you a block of ice, could you explain to me what would happen to the ice, holding it in your hand?
Well, it would slowly melt because it's obviously out of a freezer, and your hands aren't the coldest to keep it like cold and frozen. And from it being in an enclosed tight space with your hands, it could like slowly melt because your hands are keeping it warm.
Okay, yeah, cool. So just to clarify, when you have the ice cube in your hand, because your hand changes temperature, doesn't it? Yeah. So does the ice cube give your hand cold or make your hand cold, or does your hand give the ice cube the heat, or is it both? Does that make sense?
Yeah. Well, it's both because your hand is making the ice cube melt and the ice cube is making your hands cold because the ice cube isn't going to go like a warm ice cube. It's going to stay cold, but it's slowly going to melt down.
So would you say that the ice cube is giving your hand the cold?
Yes. Because it's the cold. Like, it's a cold ice cube and your hands are like... Yeah.
Yeah.
It's
No,
giving,
yeah, that's good.
It's giving.
Okie dokie. So... thinking about the ice cube and the change that's just been made in your hand, we would say that it has changed state. So let's say from when it started to let's say it's completely, yes, it was a solid. And then if it stayed in your hand for long enough, what would it become?
A liquid.
A liquid, yeah. Can you tell me, so there's actually 3 states of matter. Can you tell me what the other one is?
Solid and liquid.
Ah, look at you. I actually did a diagram for you. So you've already done those. So can you point to me which one is the solid? Which one represents the solid, liquid, and gas?
This is the solid.
Yep.
This is the liquid. And
Yep.
This is the gas.
Perfect. And when it goes from a solid to a liquid, Is it dissolving or is it melting?
It's melting
Melting.
because that's evaporating.
Yep, I did these ones for you. Yep, cool. And then when it goes from a liquid to a solid, what's that called?
I'm not sure.
That's
sorry.
okay. What about, I'll give you a hint, when we put water in the freezer, what are we doing to it?
Freezing.
Yeah, good job. Now, this might be a bit tricky, so it's okay if you don't know. But these blue dots, we call them particles.
Yeah.
Yeah, or you might know them as particles. Do you remember that at all? Yeah. So, can you remind me what happens when we go from a solid to a liquid? What happens to those particles?
Well, the particles slowly come apart
Mm-hmm.
and like spread apart and slowly they open it up more and disappear a little bit. Like there's not as many particles when it changes.
Yep, okay. And do particles ever change shape? Like, do they ever enlarge or shrink?
Yes.
They do? Yep.
Yeah.
Do you know what stage?
I think that's from when a solid turns into a liquid.
Okay, yep. And we are almost done. Now, can you imagine, and I can get a video up if you like, but if we were to turn a kettle on,
Yeah.
can you explain what happens to the liquid inside the kettle when we turn it on?
Well, the kettle's heating the liquid, so it forms a little part of it into gas, so that's the steam.
Perfect.
And it makes the water hot, it warms it up.
Yep.
And turns it hot, and then steam comes out of it, which is gas.
Yes.
And yeah.
And what happens to the particles inside the kettle?
Well, they would probably spread apart, or some of them would dissolve.
Yeah?
Yeah.
When it goes into steam, do you mean?
Yeah.
Okay, cool. And you've already answered that the steam is when it comes out and it's the gas.
Yeah.
And so what happens, did you say what happens to the particles when it's steam?
Well, when it's steam, the particles disappear.
They disappear. Cool. All right. And does water always boil at the same temperature?
No.
No?
Because the kettle does have an assigned temperature, but it depends, the kettle only goes for a certain amount of time.
Yeah.
It doesn't have the exact temperature. Say if you were to put freezing cold water in a kettle,
Yeah.
it would heat it up a fair bit, but it wouldn't be the same as if you put hot water in a kettle to make it even hotter. It wouldn't be the same as cold water.
So the temperature on which it boils or turns into steam is different depending on what temperature it is to start with.
Yeah.
Okay, cool. And that's it. Can you believe we're done?
Alright.
That's all it is. So thank you so much.
It's okay.
That's done. We're all done.